Okay, so we're looking at homework from section 3.2, and we're looking at question number 3 right now. Let's take a look at the question. Explain how the complement can be used to find the probability of getting at least one item of a particular type. So we have several possibilities here. So let's remember how we defined a complement back in section 3.1. The complement of event E is the set of all outcomes in a sample space that are not a part of E. So the complement of E is written as E prime, E with an apostrophe right next to it. Remember that the probability of the event E is 1 minus the probability of E prime, and that the two probabilities, the probability of event E and the probability of event E prime, will always add up to 1. And also remember that if E happens, E prime does not, and vice versa. If E prime happens, then E does not. They cannot both simultaneously occur. Okay, so we've got a little drawing here, and you can imagine that this drawing is our sample space, this oval. And we're going to break it into two parts, okay, complements, because complements will eat up the entire sample space. So the first thing we're looking for is getting at least one item, because that's what was asked of us in the problem. It said, explain how the complement can be used to find the probability of getting at least one item of a particular type. So you could imagine, let's say there are 30 items available. You could get one item or two or three or all the way up to 30, right? All those things would fall under getting at least one item. What wouldn't fall under that umbrella? And the answer is getting no items. That's the opposite, right? So those two things together, getting at least one item and getting no items at all, form the entire sample space. So when we look at this, choice C is going to be our answer. The complement of at least one is none. So the probability of getting at least one item is equal to 1 minus the probability of none of the items. Now, B was close, but you'll notice at the end the subtraction is reversed, right? It has, in choice B, it has probability of none of the items minus 1. But in our definition on the left-hand side, we say that the probability of the event is 1 minus the probability of the complement. So we're looking for 1 minus, right? Not the probability minus 1. So that's why we chose C instead of B. And that's your answer.